Hello everyone, Zeta Math here to introduce you to the puzzle of the week number 3. This week, that puzzle is the finale of Bitty Bytes 2 by Clover. So if you've not seen it before, Bitty Bytes 1 and 2 are a collection of somewhere on the order of 30 puzzles that are all little 4x4 Sudoku grids that Clover made. So as you would expect, a lot of them you can do pretty quickly. But as you might not expect, a lot of them are also quite toothy. They'll be quite challenging in interesting ways. The puzzle I've included here as the puzzle of the week is the finale, which consists of 9 disjoint sets of 4x4s that you connect in various ways, and it's just awesome and fun. I really encourage you to give this puzzle and the rest of Bitty Bytes 2 a try if you haven't yet. And if you're interested, all of my solve of Bitty Bytes 2 is available in the VODs on this stream. So if you want to go back and see even more of my enjoying how clever Clover is, there's links to the VODs below. But without further ado, enjoy this puzzle by Clover. Okay, so let's fill each grid with a set of 4 digits from 1 to 9. So kind of like the previous puzzle, each 4x4 has its own set of digits. In normal 4x4 Sudoku fashion, the correct set of digits to use in each 4x4 grid must be determined. No digit ever appears in the same position in 2 different grids. So that means that this is sort of like a weird disjoint puzzle where for every position, if I look at all 9 grids, that position will have all 9 values in some order. Yeah, it does occur to me, maybe YouTube will help you stream YouTube videos to YouTube. It seems like the kind of thing that YouTube might actually help you do. See. Okay, digits appearing outside of the 4x4 grids are non-negative integers, but are not necessarily in the... Wait, digits appearing outside? Oh, so are we actually putting a digit here? Is that what this is saying? Sorry, let me read this again. Digits appearing outside the 4x4 grids are non-negative integers, but not necessarily in the range 1 through 9. Standard arrow, killer, inequality, thermo, rules apply. Okay, so I do need to put a non-negative integer here and here. That's weird. Okay. And on the thermo. Okay. This is very weird. Okay. So, the final boss of Bitty Bytes 2, here it is. So, let's see. So this thermo, so my understanding is I have to put a digit here. So let's count this thermo and then goodliff it. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So 1 or 2, 2 or 3, 3 or 4, 4 or 5, 5 or 6, 6 or 7. Oops. 7 or 8, 8 or 9. Draw on edges off. We literally just talked about this puzzle last night, Tall Cat. How could you not have been aware of it? Let's see. This is a sum of at least... yeah, this is a sum of a bunch of numbers. This is some bunch of numbers. Let's see. So all of the numbers... Okay, so maybe here's a point. Oh, this number's at most 7. Because these are the 4 digits that appear in this puzzle. So because these are the 4 digits that appear in this puzzle, this can't possibly be bigger than 7. And that's got to be pretty big, because the absolute minimum that this could ever be is 7. Because this could be 1, 2, this could be 1, 2, and this could be 1. That has to be what happens. So this is 7. That's a 1. And then these are all 1, 2. So now that makes that a 6, a 5, a 4, a 3, a 2, and a 1, just percolating backwards down the thermo. Can't it be a 0 outside the grid? Oh, are non-negative integers. Sorry, you're right. Okay, so right, it could be a 0. So this is a 0 or a 1. Right. So there is a degree of freedom. Sorry about that. So that means that I don't know that this is a 7 yet. This is a 6 or a 7. Okay, so this is a 0 or a 1, and then these are all from 1, 2, 3. Oops. No, please unselect that. 1, 2, 3. Okay. Good point. Sorry, I missed the non-negative trick. But that does, as pointed out, give us a 6-7 pair in this row. So that means we know that 6 and 7... Oh, it's even better. So 6 and 7 are numbers in this puzzle. So that means this has to be a 6. Because I need to... Wait, does it? Maybe it doesn't. No, yeah. Sorry, this has to be a 5, because this digit... No. Don't listen to me. I'm being confused. Yeah, if this is a 7, it doesn't work. Because if this is a 7, I put a 6 on the thermo, and now I don't actually have 7 as one of my digits. So this can't actually be a 6. This can only be... Sorry, this can't be a 7. It can only be a 6. And that be a 7. So that does eat our degree of freedom. This is a 0, and these are all 1, 2 pairs. Okay. So now we can go ahead and place the 6 and the 7 here per Afraid Not's point. That's going to place a 7 up there. Now we know there needs to be a 6 on the thermo, so the 6 on the thermo has to go there. The remaining 6 has to go there. This has to be a 3 or a 4. This is a 4 or a 5. And the fact that this is a 4 or 5 is very interesting. Because that's already a pretty big digit to be appearing on an arrow. Let's see. So, yeah, and so... Probably want to go ahead and give this a color, this 4, 5, because I know where it goes here, and so I know where it goes here. And then we can give this a color. No, I wanted that one. That one, that one, that one, like that, which means that this is a 7. How did I not fill in that this was a 7? I don't know how I failed to fill in that that was a 7, but anyway, that's been a 7 for some amount of time. These are 3, 4, these are 4, 5. Okay, so that is all well and good. So 1 and 2 are the values along this diagonal. So I'm interested with what's going to happen between this diagonal and this diagonal. Yeah, we can finish the thermo. Because those diagonals all overlap, and they all want to have low digits on them. So the absolute minimum, this could be 4 plus 0 plus 1, 2 plus 1, plus 1, 2 plus 1. So the absolute minimum this works out to be is an 8. So this is either an 8 or a 9. Now, this is a 0 or a 1. And so these are from 1, 2, 3. This is a 1 or a 2 because there's a degree of freedom. But I want to pay attention in particular to the fact that that gives us a 1, 2 pair in this position. So this digit is actually at least 3 now, for whatever that's worth. Probably not worth a whole lot, but it's worth keeping track of that kind of thing. Hey, Alex, welcome. This arrow, this thing can't be a 9 anymore. For whatever that's worth. These are at least... Okay, these don't overlap with anything, so that's at least 3, 4. Yeah, Peter, thank you. I'm looking forward to watching it and trying to do a live reaction video and seeing if we can figure out how to make that work. It will be its own little adventure, I am sure. So I'm still trying to just hunt down a tiny bit all these overlapping sort of 1-2s. So if this isn't a 3, then we're saying these two cells are each at least 3. But that's not a huge deal. Is there any possible way that this could be a 5? I don't think so. I'm trying to figure out, like, this 1-2 is one of those 1-2s. I'm trying to figure out if I can sort of, like, chase it around. There has to be a 1 on the grid 3 arrow. If not, yeah. If not, then I break my 1 degree of freedom. So yeah, 1 is one of the digits that has appeared on here. That is a good point to J40. So actually, if I use a 3, then the digits in this grid are forced to be exactly 1, 2, 3. Let's see. So the 14 cage. What can the 14 cage be? There, it could be 9 is the bigger digit, 5 is the smaller digit, 8 is the bigger digit, 6 is the smaller digit. I think those are the combinations to make 14. Unless 7 is the bigger digit and 7 is the smaller digit, but I can't do that because I already have a 7 there. So those are my combinations up here. For the 13 cage, there's more options. So this could go as far as 9, 8, 7. So this would be 4, 5, 6. Sadly, we're not yet at a point where any of these are overlapping anything. Let's see, the 12. This needs to be 7, 8, 9. This can be 3, 4, 5. Don't quite have... So I'm beginning to think I might be trying to form a 7, 8, 9 triple in lower left box. Row 4, column 1. Why could this not be a 7? Or what's... This is a 6. 6 is the only digit we've ruled out of this. The 6 in box 5, looking at the 14 gauge. I don't think that these things look up here because the thing is that you can't repeat a digit in the same cell. I will reread the rules just to make super sure. It's in the same position in 2 different grids. So I can't repeat a digit in the same position in 2 different grids, but I don't see I don't see how that affects this. Yeah, this 7's on sort of the other side of this one. Yeah, so let's see. So someone was saying this is from 7, 8, 9. Let's see if we can make that true. Because if this is from 7, 8, 9, that's actually big because it gets us a 7, 8, 9 triple. So it can't be 6. So the only thing we have to rule out is why can this not be 5? And if we know why this can't be 5, then I'll be content. And it probably has to do with looking at these overlapping diagonals together. So that cell's a 1 or a 2 there. It's a 1 or a 2 here. So it has to be at least 3 here. Let's see. Because row 2, column 3 is at least 3. I agree, that's at least 3. And row 3, column 2 is at least 2. Okay, why is this one at least 2? If this were a 1, it would make that a 2 and that a 3. Okay. No, we don't actually... Are we guaranteed there's a 1 used in this box? That's the point. We're guaranteed, actually. I had not actually previously proven this, but it's true. Because we only have 1 degree of freedom, one of these two has to be a 1. I can't possibly get away with making this a 2 and a 3. That's already too big. So yeah, there is a 1, actually. I can just get rid of this corner mark here and actually think about it. Yeah, so there is a 1 here. I had not proven this before, but there's a 1 in one of those two and a 1 in one of these two. So this can't be a 1. So this is at least 2. This is at least 3. This is at least 1. So this is at least 6, but it can't be 6 because there's already a 6. So this is 7, 8, 9. And so that means, for whatever it's worth, all of these remaining cells are from 1, 2, 3, 4, 5. Probably not worth a whole lot, but it's true. Okay. Oh, and not 1, because we actually know there's a 1 there. So yeah, actually, from 2, 3, 4, 5. Top left grid, row 4, column 4. Sorry, row 4, column 4 repeats in row 1, column 3. Right, because this cell can't be a 1 or a 2. Ah, that's really clever. Okay. Let's give that a color now. You can be yellow. No, yellow. You go there. So yeah, this cell's a 1 or a 2, because this cell can't be a 1 or a 2. That's gorgeous. Okay, that's really, that's very slick spotting, Alima. Okay, so that's a 1 or a 2. Hey, SPQ, how are you doing? I'm looking at 4, 5, 6s in these cells just briefly. Like if this is a 5, then that's a 6. Doesn't really seem to do anything, but it seemed worth looking at for a second. Ah, yeah, okay, good point to Christoph. The arrow tip, actually, has to show up in this box somewhere. And the only place it can show up in the box is there. So these two are actually the same digit, which means that's that digit and that's that digit. No, sorry, and that's that digit. So these are 7, 8, 9. Let's see. Would sure be nice if we knew that this was yellow 1, 2. let's see, what if this digit is at least 3 and this digit is at least 3? This could be 3, 3. Then this would have to be 1 or 2, but that seems okay. But that was a really good spot, Christoph. Do I know that yellow 1, 2 goes here? I would love to know that yellow 1, 2 goes there. But I don't think I do. Color row 2, column 3. Okay. So, yes, my beloved bringer of tea. Okay, so that digit certainly goes there. That digit certainly goes there, so it goes there. Yeah, I don't think that answers the question of whether this cell is yellow or not. What do I know about the value of purple? I know purple is at least 3. What's the most purple can be? Maybe that's not an interesting question, because maybe I could have... this could be like 5 with this being double 2 or something. It puts a lot of pressure on the other arrows if it happens that these are not that. And welcome, Ken. Let's see. None of these cells show up anywhere, I don't think. So I think I only know that this is at least 4, which is not a huge restriction. If blue is 3... Let's see, I'm looking at Garian's point. If blue is 3, then you can't make purple 3 in the top left box. Agree, yep. So this is... there is this connection. And notably, if blue is 3, yellow is 1. But the blue doesn't immediately seem to show up other places that I can see. Let's see, and there's no place where red touches the same place that a 7 touches, right? In any of these other puzzles? No, I don't think so. Oh, but no, sorry. Purple can't be 9. That is not exciting. I was briefly excited by the fact that purple was not 9, but that is not a good deduction. I mean, it's true, but it's not an interesting deduction. I'm very open to using the fact that each digit has to show up in exactly one grid. I just don't know how to use it. I feel like that's going to be very useful once the puzzle is getting closer to finished. Because once that happens, then we'll be able to say, like, we don't have this digit showing up somewhere yet. And then it will sort of start pulling things apart. See. I know this digit's at least 3 because this digit's in the 12 cage. So this digit's at least 3, plus these are at least 3. So actually this digit here is a 7, 8, 9 as well. Because if I look... Sorry, it could be a 6. No, it can't be a 6. So here we go. So I think this is useful. This digit appears in the 12 cage. So it is at least 3. These are at least 1, 2. So that means this circle is at least 6. But it can't be 6, Sorry, it can't be 6 because it's in a 12 cage, and it can't be 9 because there's a 9 in that spot. So actually, this is a 7 or an 8, and this is a 4 or a 5. So that seems interesting, possibly. Let's see. So the 7, 8, 9. Yeah, this cell. Good point. We can do more coloring. Christos sees this cell. Let's make it green. This cell can't appear on the arrow because this arrow is at most 7 or 8. So it has to show up somewhere here. So this can be 7, 8, or 9. Now, actually, this cell can't be bigger than 5. So actually, this cell is at most 5. So in fact, these two cells are the same. Okay, sorry. I need to figure out what brown is to make a color because I'm running out of colors that I know by heart. Surface brown. Brown is 12. Okay, these two are the same digit as well. So that is interesting. And so actually we could do more coloring, like these two cells are the same. Yeah, we can actually finish green, because where does green go in row 4? I did not see this, but Afraid Not pointed it out. That has to be green, and that has to be green. So that's 7, 8, 9. That's 7, 8, 9. So that is where the green goes. I guess this 3, 4, 5 could show up on the arrow here as long as it's with a 1. I don't think I know anything about 1s in this spot, so I think there could pretty freely be a 1 here. I do just adore this puzzle, by the way. This is super sweet. Let's see. 7, 8, 9 for the upper right corner. Let's see. There's no other... there's a... So we have a 3, 4, 5 in 2 places. Or in 2 of these places. That's interesting. What about this cell? Yeah, brown and orange are sort of interesting. There does need to be a 1 or a 2 in here. I can't get by without a 1 or a 2. But I don't think I need a 1 or anything crazy like that. Sadly, this 4-5 does not see any of these other 4-5 businesses, I do not think. This can only be a 5 if this is a 1-2 pair, for the record. These 7, 8, 9s are now actually lining up. sadly not immediately clear how those are going to resolve, I don't think. I'm interested in like what the overlap is between the 13 cage and the 14 cage and the 12 cage and the 11 cage. But I don't think I quite know enough to say. But I think that that is an interesting question going forward to ask. Yeah, purple is at least 3. We know the purple is marked, Nicholas, because of that observation. That this is a 1-2 pair, which makes this digit at least 3. I'm now briefly having terrifying visions of setting this puzzle and how horrible it must have been to try and get this to work out in this way. Purple may do something interesting with blue. So what can purple actually be? We know purple is at least 3. Pretty clearly purple is not larger than 7, but I suspect 7 is way overshooting it. So could only be 7 if both of these cells were 1. Is there any way both of those cells could be 1? Unfortunately, I don't see how I'm ruling out that both of those cells are 1. It would make yellow 2, of course. Box 3 and 7. Oh, that's right. This one can't be 1. This cell is at least 2. So, right, this is at least 2. So this can't be a 7. Oops. Because, oops, whatever I did there is not what I wanted. Not 7. Because we have a virtual 1-2 pair in this diagonal. So this can't be a 1. It could be a 2. So is 6 possible? That would require a 2 and a 1? Maybe? That sounds fishy as well. If this was a 1-2 pair and that was a 1-2 pair. That seems very sus, but we certainly need a 1 or a 2 on this arrow. We cannot get away without a 1 or a 2 on the arrow, but unfortunately I don't know what that tells us. Bottom right corner. It's not yellow. Why isn't this yellow? I'm trying to decide if there's any way I can connect which is yellow to this box or this box so that I could actually have yellow cross puzzle boxes. Because I think if I can get yellow across puzzle boxes, that might actually be useful. So here's an idea. Let's color this 1-2 pair. So I'm going to use some colors for this. Okay, so this is going to be pink. So this can be some non-pink color, like dark gray, I suppose. And so this is dark gray. Now, the question is, do I have any idea how that connects over down here? And I again fear that I don't actually know anything. That's a really good idea, Judith. If I were setting this, I might be inclined to do something like that, where like everything here is just a permutation mod 9, so that you're guaranteed that this works out. In box 1, if row 3 column 2 is more than 2, it must appear on the arrow twice. If this is more than 2, yeah, then it's not purple. So if this is more than 2, it then shows up there as well. So this can't be more than 2, because then that would make the total too big. So this cell is always a 1 or a 2. Which is great, because that gives us our 1-2 pair, which makes this cell a 3 and resolves the world. So great spot to calzone. So let's re-go over this just to make sure we believe it. So now the absolute minimum I could put here would be 1, 3, 1, would be 5, 0, 4, and that is the best. Okay, so yeah, so this is 1, 1, 4, 0, 9. Okay, so I think we can get rid of the coloring of these now, because now they're just going to be digits. Oops. So now, yeah, now we're going to resolve the world. So now that 1 makes that a 2 and that a 1. That 1 makes that a 2 and that a 1. That 1 makes that a 2. Orange is 4 now, so the fact that orange is 4 fixes the thermo back like this. So in fact, this is a 1-2 pair going on in this puzzle. So that's a 2, that's a 2, that's a 1, that's a 1, that's a 2. So this is 2 and 2. So this certainly can't be 6 anymore. Let's see. Now, what else is that? Oh, so blue is 3. I should fill in that blue is 3. 3, 3. Blue being 3 means purple's not 3. So purple is at least 4. Purple being at least 4 now means this isn't 7. It's at least 8. So that is an 8 or a 9. So one of these two is a 7, for whatever that is worth. This isn't a 2 anymore. That's not a 2 anymore. That's not a 2 anymore because of disjoint nonsense. Let's see. Do any of these cages overlap anything in an interesting way? I don't think so. Brown can't be 4, I see from chat. That's true. Brown can't be 4, so green's not 8. Agree as well. Let's see. We can uncolor the 1s, because the 1s are just 1s. These aren't 7 either. Okay, so does this 1, 2 put pressure anywhere else? So this cell can't be a 1. It's at least 2. but this cell I think could still be 1. Oh, there's disjoint Sudoku to do in box 1. I mean, there's just regular Sudoku I can do in box 1, I suppose. So I can place a 2 here, and a 2 here, place a 1 there, and a 1 there. And now, let's see, is that helpful? If so, where? Yeah, okay, so we can continue up here. There's a 1 by Sudoku. There's a 1 by Sudoku. Okay. Neither of these, I think, sees any of the 1s, unfortunately. So I could color this entire box. I don't know if it's worth it. 3s and disjoint. Okay. So the 3 is placed by disjoint, Martin points out, is correct. 3 can't go here because it would mirror that 3. So in fact, that's a 3, which makes that a 3, which makes that a 3. Great spot. So now that's a 9, because I need a 9 in this row. So that's a 9 because I need one for this box. That's a 9 because I need one for that box. Do any of those 9s see any cells that I ever wanted to be 9? I fearant that they don't. Yeah, I do not see any. Let's see. Do any of them see this? Somehow I missed all of these. Yep, we exactly missed all of these. But that's okay, I suppose. Now, do any of those 3s see this 3, 5? They do not. I do not believe. So if brown is 3, the only place in row 1 that's allowed to have a 3 that brown could go is there. So that would be a 3 and that would be a 3. So if brown is 3, the 3s end up looking like that. Does that break anything? Not that I see, unfortunately. Let's see. Box 4. Does box 4 need 1s? Let's see. Do we know that oh, yes, I do know this isn't double 2. So, yes. So if there were no 1s, these would sum to at least 5 plus 3? I'm trying to convince myself I know that there is a 1 in box 4. So if there's not, then I would need this to be 2 and 3. The 3 couldn't go there. It could go there. Oh, but then if this is 3, this is 5, and so then it's way too big. Okay, yes, I agree. Because if I want to minimize this as at 2, 3, then this can't be 3. That's the point. And the 3 can't go here by disjoint Sudoku. So it's pretty complicated to put all the pieces together. But anyway, this definitely has a 1 on it, and the 1 has to go here. By disjoint, it cannot go there. So that's a 1. So now I need to put a 1 in this row. It can't go here by disjoint, so the 1 goes there. So the 1 goes there. So the 1 goes there. That was awesome. Let's see. Yes, arrow digits can absolutely repeat, but they could not repeat if I literally put this looking at a clone of it. That was the point, Nicholas. But yeah, arrow digits can repeat in normal situations. Okay, have I now placed 1s in strategic positions that are going to make this arrow interesting? 2, 3, 4. Oh, well, ones are just done overall. There are no more ones in the entire universe because I've now placed ones in 4 grids. So no grids have ones anymore. So this arrow now needs to actually sum to at least 5. So this is 5, 6, 7, 8, 9 naively, but it's not 7 because there's a 7 in that spot down there. At the very least, that might be the best I can do, is that it's not 7 for this particular moment in time. Grid 4 arrow can't be a 7. Let's see. So these two are odd. So in order to make this a 7, this would have to be an even. No. This would have to be odd. So So why can't it be 313? It can't be 313 because this cell is not allowed to be a 3. So this cell would have to be at least a 5 in order to make this a 7. That's not ever going to happen. So that's an 8 and that's a 4. That was a great spot I think it was a Lima. Yeah, that was a really slick spot to see that this couldn't be a 7 because that was not an easy thing to see, I don't think. Hey, Carl, welcome. So I might use neither of 8 and 4 in this 11 cage. I'm trying to think how the 8 and 4 is going to inform the 11 cage. Okay, so now this is summing to 8. 8 is even. The sum of these two is even, so this digit has to be even. So this is either a 2 or a 4, based on whether this is a 3 or a 5. I don't yet think I know anything about this from Sudoku, or sorry, from disjoint stuff, but I know that's a 2 or a 4, that's a 2 or a 4, and that's a 2 or a 4. Ah! Aha! But now, if I chase this cell around the grid, it ends up here, and that tells me it's not a 2, because there's a 2 there already. So it's a 4. That's slick. That's awesome. Way to go, Clover, on this puzzle, by the way. This puzzle is insane. So that being a 4 makes brown 3. So now that's a 3, that's a 3... that's a 9, a 9, a 9, and a 9. I can get rid of the coloring on all of that. That 9 makes this an 8 by disjoint. That makes purple 4. I can again get rid of that color. So that makes this not 8. Which makes this not 5. This is 7 and not 7 or 4 or 6. Scanning just to see if there's any more disjoint nonsensicalness. Also not 9. Yes, good. Not 9 because of that 9. Thank you. Thank you to many in chat who saw that. This has gotten a Q in it, but we won't think about that too hard. So this is 7 and 6. So this is not a 6 either. Now, has it become impossible that this is a 5? Yes, this can't be 5 anymore because this would have to be 2, 3 exactly. Remember, 1s are gone. But actually, 3s are gone in both of these places. So this can no longer sum to 5. This arrow sums to 8 or 9. So that is very large as these things go. Let's see. I don't think I know which of 8 and 9 that it sums to yet, however. I know that these are 7 and 6. I don't know if it's worth recording. Oh, it is worth recording. These are 6 and 7, but I actually know the order because there's already a 6 in this spot. So that's a 7 and a 6. And that's huge because that 6 tells me that that's a 5, and therefore that's a 9, which tells me that that's a 9, and therefore that's a 5. 5, 6, that's a 7, that's a 6. So now I can fill in the rest of these. So these are 6, 7, 5, and 9. 6, 7, 5, and 9. 5, 9, 6, and 7. That 6 looks up there and sees that 6. So that's a 7 and a 6. Let's see. This 9 looks and sees that 5, 9. So that's a 5 and a 5 and a 9 and a 9. So that is going to do tons of work. So we've finished 4 grids now. So that's all good. Okay, so this is a 9. Let's look at these cells and figure out how we're making 9. Someone in chat said there's no 4 on it, so it's not 4, 5, and I agree, it's not 4, 5. There's no 3 on it, so it's not 3, 6. 3 and 3. It's not 3, 6. There's no 1 on it, and so it has to be 2, 7. So this is 2 and 7. Do I know the order of the 2 and the 7? It appears maybe I do not know the order of the 2 and the 7, but this is a 2 and a 7. That's cool. 3, 4, 5, 3, 4, 5, 3, 4, 5. I assume we're just going to get the last digit in this grid by Sudoku at some later date. The 11 cage can't be 2, 9. Right. It can't. That's really clever. Okay. Yes, the 11 cage can't be 2 or 9 because this can neither be 2 nor 9. Good spot. I was trying to look for neither of them can be 2 or neither of them can be 9, but that doesn't work. But the top left does tell us this is not 2, 9. So if this is not 2, 9, could it possibly be 3, 8? Let's see. It looks like it could be 3, 8 if it's in that order. And then the only other option is 5, 6. No, sorry, 4, 7 is also possible, maybe. Yeah, 4, 7, but it would have to go in that order. And 5, 6, it would have to go in that order. I believe. Are any of these numbers seeing something by disjoint? Oh, I'm told we already have 4 grids with 4s. So that must mean there is a 4 in this spot somewhere. Oh. So, no, there's not. But we have 1, 2... So that's actually an excellent spot. We have 4 grids with 4s. So we can't put any more 4s. But actually, that also tells us we can place all the 4s here. So... the 4s in this, the 4 in this row can actually only now go here by disjoint. The 4 in this row can only go, which of these is it? The 4 in this row can only go there by disjoint. So now that's a 4. These aren't 4. Excellent spot to whoever said we already have 4 grids with 4s. That was Brian. That was a very good spot. So now this 11 cage can't have a 4 in it. So it can't have a 7 in it either. Let's see. Could it be 2, 9? It cannot be 2, 9 because there's a 2, 9 over here already. So not 2, 9. So could it be 3, 8? Let's see. No, because there's a 3 in both spots. So it has to be 5, 6, I think, if I did that right. And we know the order. 6 and 5. So if we believe that, then that's an 8, that's an 8, that's an 8. Let's see, what am I missing? I am missing a 6 in this column. I am missing a 5 in this column. And then these digits are a 5, 6 in some order, and I know which order because of that combination. That's an 8, not a 5. That's a 5. That's a 5. That's a 6. That's a 6. That's a 6. Okay, so there we go. Okay. So, yet more fun stuff here. Okay, so now Martin is suggesting we go back to box 6. So back to box 6. We put a 6 here, so now this can't be a 6 anymore. So that is an 8 and a 3. This puzzle is so much fun. So these I know are 2 and 7, and so the 7 goes there. So that's a 2, that's a 7. I know now, oops. I know now that's a 2. So that's a 3. Let's see, this is an 8. There aren't actually 5s in this puzzle, so that must be a 3 and that must be a 5. Let's see, that's a 2. Let's see, this is not 2, 3, or 8, so if it's not 2, 3, or 8, it's a 7. So the last 7 goes there. The last 8 goes there. Sorry, not the last 8, but that 8 goes there. That 8 goes there. That's a 3. That's a 2. That grid's done. Okay. So all kinds of fun stuff going on now. Okay, so top left corner. I think we have to probably resolve this by looking at the top left corner. Actually, let's not look at the top left corner. Let's look at this cell, where literally all but one of our things is filled in. So this is now not 1, not 2, not 3, not 4. It is 5. It's not 6. It's not 7. It's not 8. It's not 9. So that's a 5. Let's see. Do we know which of these is allowed to be 5 in this universe? I don't think I know which of those is allowed to be 5. Do I know which of these is allowed to be 5? I don't think so. So top right corner, we can do the same trick. So in top right corners, I have a 1, 2, 3, 4, 5, 6. I need a 7, so that digit's a 7. So I need a 7 down in one of these two cells, and I know which one. It's got to be that one by this grid. So now I need a 7 in one of these two cells, and it has to be this one. Sorry, one of these two cells, and it has to be this one by the central grid. Well, that's a 7. Okay, this cell, we can actually figure out what it is as well. It's not 1, 2. It's not 1, it's not 2. I think it's, it's not 3. It's not 4. It's not 5, or, it is 6. Because then it's not 7, 8, or 9. So yeah, so this is a 6. So now, which of these two is 6? It's that one by this cell. So now that's a 6. Let's see. The missing digit in this row is a 6. The missing digit in this box is a 9. So these are a 5 and a 9 in some order. Do we know the order? Yes, we do from this one. So that's the 5, that's the 9. And that's the 5, and that's the 9. Okay, so that's all well done. Okay, so now this cell we have in every grid except this one. So we've got a 1, a 2, a 3, a 4, a 5, a 6, a 7, and a 9. So this had better be an 8. So that's 8, that's 8, that's 8. That's 8. Let's see. And now I should be able to find one more cell where we know everything, maybe? No, these two... Okay, so these two have exactly the same space as empty, which must mean that I don't have 2 in enough boxes. I have 2 in 1, 2... I only have 2 in 3 grids, and I need to have 2 in 4 grids. So these have to be 2s. Because I can't also put 2s over here. And then we just now need to ask ourselves, okay, this is not... It's not 1, 2, 3, 4... And it is 5, because it's not 6, 7, 8, or 9. Yep, so these are 5s. Ta-da! And there we go. That was a lot of fun. Yeah, these multi-grid puzzles, I think, are quite enjoyable. This is very reminiscent. If you never did Sam Kappelman-Line's Sudoku Cube, or whatever he called it, it was like 6 6x6s that had this disjoint property. I really recommend it. It was a lot of fun. I think, I'm not certain, but I think Clover was likely inspired by Sam's puzzle. Anyway, that is the end of Bitty Bytes 2. I really enjoyed doing Bitty Bytes. That was a lot of fun. And so now I suppose... yeah, I know a lot of Clover's thing with Bitty Bytes was to take other puzzles of other people that she liked and try and make like a little bitty version of them. So I'm not too surprised that she was directly inspired by that sample.